Okay, so this is not itself a reduction of order problem. Okay, except that I'm going to reduce the order, right? But I'm not doing the full procedure here. So it just so happens that I have this equation, y double prime minus 5y prime equals 7. This should be straight easy to solve. One way in which I could solve this is I could make an auxiliary equation, right? Like I could turn this into r's, and then I could fiddle around with that. I could do method of undetermined coefficients, right? With a constant. I could find a constant. Cool, great, that would all work, right? Let me show you the kind of other thought here. So the other thought here would be, hey, there's really just y primes in this thing, right? Okay, so I'm just going to say, let z be y prime, right? So if I let z be y prime, then my equation becomes z prime minus 5z equals 7. Which is first order. How do I solve first order equations? Yeah, with a really easy formula, right?
In your sleep.
So I go like, okay, I make the homogeneous version, right, which is just z prime minus 5z equals 0. So that would tell me that z is
e to the 5x.
e to the 5x. Well, really that's z homogeneous, right? And then
We do the guess.
okay, then we do the guess thing, right? We do variation of parameters. So we guess z is, yeah, some function. Just because I'm going to use a mu in reduction of order, I'm going to call this something else, but it doesn't really matter, right? Pick some variable choice. I'm going to do a nu, just because I don't know if you guys know that letter yet. It's like a B.
I don't know that one.
Okay, so then z prime is nu prime e to the 5x plus 5 e to the 5x nu. Right? And then what do you do with this? Plug these two bits into your original equation about z's, right? Not your original equation about y's, but into the one about z's.
Wouldn't be bad.
So you get nu prime e to the 5x plus 5 e to the 5x nu minus 5 times nu e to the 5x. And this is supposed to equal 7. Notice the usual cancel thing. So now I'm sitting at nu prime is 7 times e to the minus 5x. Which I integrate,
Put the D.
slap a d-eater on there. So I got nu is
Negative 35 e to the minus 5x. Alright, we'll put it back up.
I always forget how this works.
7.
Which one do you do?
7 over minus 5?
I think I got it.
Yeah.
7 over minus 5 e to the minus 5x.
10.
Right? Because if I differentiate this thing, the minus 5 will fall down, and then it'll cancel with the one on the bottom. Cool. Good. And what did you forget?
Hey, that's not great.
Plus c maybe?
Yeah, it is. Because if you differentiate that, yeah.
Okay, then what?
Plug it into Z.
Take that back over here, plug it into
It's
z,
E's, right?
right? So that's going to come back over here, and I'm going to plug that in here.
It's just E to the X.
So I'm going to figure out from these two pieces that I got z is, oh, that's nice, the e to the minus 5x and the e to the 5x cancel on that bit, right? So I got 7 over minus 5 plus c e to the 5x. You guys all good with that? Okay, circle, go home?
No.
Crap, why not?
So we've got a
Not done.
Half of it.
Oh, they asked me a question about y's, didn't they? God damn it. Okay, so they asked me a question about y's, not a question about z's. I answered a thing about z's. So what was z?
Why prime?
Z was y prime. So what do I have to do?
Shove that back in.
So I know now that y prime is minus 7/5 plus c e to the e to the 5x. So what does that mean about y?
Y is minus 7 over 5x was
Still
C e to the 5x. It'll be a different C.
Yeah, it'll be a different arbitrary constant, right? So I'm going to call that C1 for reasons that will hopefully be obvious. And then what did you forget?
Plus C2.
Yeah, there's another constant, right? Plus C2. So that's my solution to this guy.
Can't you just do, for C1, can't you just do C over 5x?
Sure. No, C over 5 maybe.
Oh.
But yeah, I mean, it's an arbitrary constant. If you have an arbitrary constant, you divide by 5 who cares?
Still an arbitrary constant.
Still an arbitrary constant. But yeah, certainly C1 is C over 5. The important thing is not to forget this one. When you look at the problem, how do you know that you needed this one?
Because you have a second order.
Yeah, that equation is second order differential equation. It should have 2 arbitrary constants at the end. If you're not showing 2 arbitrary constants at the end, you have lost one somewhere. Probably the spot to look for it is the most recent thing you did. You guys all good with this? Okay. All right.